Okay, folks, this is question 9. Okay, we've got a picture of a wave. As ever, I really hope you've tried this question. If you haven't, then please do sort of make a use of the pause button and get looking at those questions just to make sure that you're kind of understanding what's going here. Obviously, I'm speaking quickly in the interest of time. If you need to pause it, do so you can try and process. Okay, so let's go for it. We've got here a wave. And they've done something nice here. They've measured a distance here of 6 meters, and you're being asked to determine the wavelength of the wave. Now, determine is an interesting command word. It really means work out, okay? Now, in this case, it means calculate. Now, a lot of students would write down 6, because the number here has been given as 6, and sometimes they might write 2, actually. That's quite a tempting one as well. Notice here it says determine. You have to do something here. Okay, so if the question said state, which is another often used command word, then I would expect you simply just to write something down. However, it says determine. That means you must go through a process. The process we go through here is to divide things. Now, why are we divided by 2? We take that 6 meters divided by 2 and get 3. We get 3 meters. We'll notice here, let's count how many waves. We start at a crest, we go down to another crest. That is 1 wave, 2 waves. Okay, so we've got 2 waves in our 6 meters, while the length of a wave, i.e. the wavelength, is the distance between adjacent peaks or adjacent crests, and that means we're going to divide by 2 to get 3 meters. So just be careful there. If it says state, it's very likely that you're just going to write down one of the numbers that are shown. In the case of determine, it means you have to do something else. Okay. We're then asked we're told a bit of information. We're told the speed of sound. We're told the sound wave has a wavelength 0.15. Calculate the frequency. Now, we have seen this before, okay, which is in our previous question, and it says here to state our unit. We're going to use our equation V equal F lambda. We're going to remember that F is V over lambda. We've got 330 over 0.15, which gives me 2,200 hertz. Okay. Now, again, remember this before. If you just write down hertz, you'll get a mark. You could write down kilohertz and still get a mark. Then you need to write down your number, which is matching. So I've done 2,200 hertz or 2.2 kilohertz. Either is fine. Again, 3-mark questions usually mean you have to do something extra, and I've seen another one in another video where you just have to make sure you write down the unit of, this time again, of frequency. It's a really nice thing. Just make sure that you're checking, why is this question 3 marks and not 2? It then says, explain to us why sound cannot travel through a vacuum of space. Well, sound requires particles. It's a vibration. Okay, and a vacuum is an absence of particles. So if you have no particles, no sound wave can travel, and therefore you will not have a sound wave. So that's why we often talk about in space. We have a saying, in space, no one can hear you scream. That's because there are no particles. If you have to explain what sound waves are doing, then you should use the ideas of particles. Okay, now, last one, a little bit about space. Remember, we mix up the topics. This is space physics. We've got the different stages of life cycle of a star, and we're going to try and decide what it is for the sun. Now, you've got these, and we have to pick 3 of these. Okay, so hopefully you've tried this one. I hope you have. You should be aware that the sun is going to become a red giant. That red giant is then going to become what's called a planetary nebula, okay, and then it's also going to produce a white dwarf at the end of its lifetime. Okay, now what I thought I'd do is think about the remaining bits to see what we could make here. And this one here. Our red supergiant, which is bigger than a red giant, okay, it's also red, but it's bigger, hence supergiant, will then result in a supernova, and that supernova can produce one of 2 things, a neutron star and a black hole. They're really the same thing, it's just this one's gravity is so strong that light can't escape it. So these are our options here. So just so for your revision purposes, just so you're aware of that, we've got these higher masses. So we've got a high mass star becoming a neutron star, and an even higher mass star becoming a black hole. This could be another one that you might need to know about for your revision.